What we're going to be looking at today in section 3.4 is graphing polynomials with higher orders, degrees, things like that. We're going to look at the end behaviors of a graph. So, don't know why my pen is doing this to us. Sorry. The behaviors. And we're going to look at the zeros of a graph, which, remember, those are the same things as the x-intercepts. And we're going to look at the y-intercepts. And let me... Okay, so when we're looking at these things, talking about end behaviors and everything, the first thing that we need to know is how to find the degree of a polynomial. So when we're talking about the degree of a polynomial, if I have f of x equals x squared plus 2x plus 3, my degree is my largest exponent. So this one has a degree equal to 2. It's the highest order, or the largest exponent of my polynomial. So if I have f of x equals 4x squared minus 2x to the third plus x minus 3x to the fourth, and let me make that 4 a little bit of an exponent, the degree of my polynomial is actually a fourth degree. It's not necessarily what is the first exponent I see, it's the largest exponent I see. So my degree for this polynomial is 4. We also have to know what our leading coefficient is. So our leading coefficient, the leading coefficient is the number in front of the x with the largest exponent. So our leading coefficient for this one, for my first one, since this is my leading degree, my degree of it, my leading coefficient is that understood 1 here. So my leading coefficient is 1. In the second example, my leading coefficient is not a 4 as here. The leading coefficient goes with the largest exponent, so it's actually back here, and so my leading coefficient is a negative 3. Okay, you have to look for what is your largest exponent in these cases. And it's very important that we know what the degree is and what the leading coefficient is, so that we can discuss how is the graph going to look a little bit. Okay? So let's look at a few more examples. If I have f of x equals negative x to the third minus 4x squared plus 2x minus 1, I want to find two different things. I want to find my degree, and I want to find my leading coefficient. So my degree in this case is going to be a 3, because that is my largest exponent. My leading coefficient is going to be this understood negative 1, because it's the one that goes with my leading number there. Let's look at if I have f of x equals a negative x to the 5th plus 4x to the 7th plus x to the 3rd minus 1. Think about it. What is the degree of this polynomial? What is my largest exponent? My largest exponent is 7, right here. Again, it doesn't have to be the first exponent, it's the largest exponent that we're talking about. Then, my leading coefficient is the number that's attached to the x with the largest exponent, and so that's going to be a positive 4. So we have a positive 4 there as my leading coefficient. Look at if I have f of x equals x squared times x minus 3 raised to the 3rd power times x minus 1. Here we have to be careful. This one is not FOILed out, it's not multiplied out, so we can't look at just our largest exponent. What we do in this case is we say, here's 2 x's, here's another 3 x's, and this one has an understood 1, and we add up our exponents. Because if we were to multiply this all out, that's what our largest exponent would be. So we have 2 plus 3, which is 5, plus another one, so our degree is 6. If your polynomial is factored out like this, your degree is your exponents added together. You have to be very careful between these two things. These, we're just looking at our largest exponent because they're all multiplied out. Here, we're looking at adding up our exponents. Notice the leading coefficient in front of each x is a 1. So my leading coefficient here is also going to be a 1. Okay. And we're going to come back to several of these in a moment to discuss what happens with their graphs and everything. But right now we're just trying to look at what are their degrees and what are their leading coefficients. So when we talk about the graphs, we want to talk about what's called their end behavior. Their end behavior. And what I mean by that is, on a graph for a parabola, remember, a positive parabola is going to look like this. It's going up and up. We could have it going down and down. Okay. So we're looking at what's happening on these back sides, what's happening on these ends. And we have some rules that we're going to follow. The first rule is, if we have an even degree, meaning 2, 4, 6, 8 as our degree, like we just talked about on the previous examples, finding the degrees, if the degree is even and we're looking at the leading coefficient, a, and a is positive. Okay? Think about what happened with the parabola if a was positive. Which way did it open? It opened up. So our end behavior, if a degree is even and a is positive, is it's going to be going up on both sides. we don't know what's happening here in this middle. We're going to get to that, but we know that it's going to go up and up on both sides. If a is negative, what do you think is going to happen? It's going to be pointed down and down. So if the degree is even, our end behaviors are going to be going in the same direction. If a is or our leading coefficient is positive, they're both going up. If it's negative, they're both going down. Again, that's if our largest exponent is even 2, 4, 6, 8. Okay? If we have an odd degree, okay, this is like our 1, 3, 5, 7, and a is positive. Think about what happens with a line. Think about slope here. If we have a positive slope, it's going this way, right? So this is positive slope. The same thing happens with our odd degrees as our slope. If a is positive, we're going to start out by going down, and we're going to end on the right hand side going up. Again, we don't know what's happening in this middle portion here. We will determine all of that using other items. So if a is negative, think about what happens with negative slope. Negative slope, we're going down. So this is negative slope. We're going down. Same thing happens with this. We're going to be going downhill, is what we call it. Okay? So for even degrees, we want to go back and think about our parabolas. Positive is going up, negative is going down. Odd degrees, we want to go back and think about our regular lines, think about slopes. Think about what happens with those. Let's go through and look at some examples and just determine what is their end behavior going to be. So let's look at if I have f of x equals negative x to the third minus 4x squared plus 2x minus 1. Okay, gonna ask you, what is the degree of my polynomial? My degree is 3, my largest exponent. Okay. What is my leading coefficient, or my a? Is it positive or negative? Well, if this is for my degree, this number is for my leading coefficient, and so it's going to be negative. So my degree is odd, and my leading coefficient is negative. That means that my end behaviors are going to look like this. It's going to start out up top and end down on the bottom. Let's look at another example. If I have f of x equals negative x to the fifth plus x to the third plus 4x to the seventh minus 1. Again, ask yourself the same questions. What is the degree of the polynomial? The degree of this one is actually the 7, the largest exponent. Okay? So we're looking at the degree of 7. our leading coefficient, is it positive or negative? Well, since this 7 told us the degree, that means that I look at that number right there to determine if my leading coefficient is positive or negative. My leading coefficient is positive. Therefore, my end behaviors are going to be start out on the downside, end on the positive side. Let's continue looking at a couple of other examples. If I have f of x is equal to x squared times x minus 3 to the third times x minus 1. Again, this one we have to find our degree a little bit differently. This one is where we add up our degrees. So the degree of my polynomial, 2 plus 3 is 5 plus another 1. The degree of my polynomial is going to be 6. The leading coefficient, look at the numbers in front of my x's. Are they positive or negative? They're all positive, so my leading coefficient is going to be positive. So my degree is even, and my leading coefficient is positive. So therefore, I'm going to have end behaviors that look like this. So hopefully we're beginning to get a little bit of an idea, of what the end behaviors of a graph are looking like. We still need to figure out what's going on in the center though. Because these two lines obviously don't connect, we don't know what's going on in the center right now. So what we're going to do is when we graph these things, when we're graphing, we need to look for end behaviors. We need to identify the zeros, or the x-intercepts. And we need to look for the y-intercepts. If we have those things, we can graph it. The x-intercepts, we're also going to have to look at, does it go through, or is it going to do what we call bounce? And I'll continue explaining these in a moment. Okay? Let's see. If I have something that looks like this, f of x equals x minus 2 to the third times x plus, let's change that to a 4, x plus 4 squared. Okay? And for some reason that's not wanting to write my, there we go. Okay. When I want to find the zeros of this one's already nice. It's already factored for us. To find my zeros, my x-intercepts, remember that is when y is equal to 0. So it's the same thing as setting my equation equal to 0. Nope. That should be a 2 times x plus 4 squared. For these, all I'm going to do is set each of my parentheses equal to 0 and solve. The exponents we will get to on what they mean, okay? But it's already in factored form, So what we're going to do is just look at the actual factors. Therefore, x is equal to 2 and x is equal to a negative 4. Now then, the exponents. They do mean something. Because if I were to write this out, that would be that I have x minus 2 times x minus 2 times an x minus 2. 3 different times. So what that means is this x minus 2 has what we call a multiplicity of 3. It occurs 3 different times in our graph. The negative 4 has a multiplicity of 2. So it occurs twice. Okay? And it's very important that we know these things, because if we have an odd multiplicity, so an odd multiplicity, which means it occurs 1 time, 3 times, 5 times, so forth. On the graph, it is going to go through our point. What I mean by that is over here on our graph, such this x equal to 2 has a multiplicity of 3, so it's odd. So if I come over here and x is 2, so at that point it's going to go through the graph. Now I don't know if this is the correct direction or not, but for right now it's going to go through the graph at x equal to 2. And that's what this multiplicity, odd multiplicity, actually means. If we have an even multiplicity, if there's an even multiplicity such as 2, 4, 6, and so forth, it's going to do what we call bounce. It bounces at that point. Okay? So let's come over here and, well, let me draw it on the same axis. So looking at the same one, here's negative 1, negative 2, negative 3, negative 4. So what this negative 4 with a multiplicity of 2 means is that it's going to come down and touch negative 4, and then it's going to bounce back up. So we're going to bounce back up at negative 4. Or if it was coming in from the other direction, it could bounce back down, depending upon which direction it's coming in from. So an odd multiplicity is going to go through the point. An even multiplicity is going to bounce at that point. So let's look at an actual example where we can start and go through and actually graph the function completely. Okay? If I have f of x equals an x plus 3 times 2x plus 1 times an x minus 2. Okay? So the first thing that I want to know is, what is the degree of this polynomial? Well, this one has an understood 1 exponent, this one's an understood 1 exponent, and that one's an understood 1 exponent. So the degree of my polynomial is a 3. So I have a third order degree. My leading coefficients are all positive, so I know that it's positive, which means the end behaviors, if you recall, are going to start from the bottom and go to the top. And these are some things that we can usually look at first thing and find out, is the degree, the leading coefficient, and the end behaviors. Now then, to actually solve for our zeros. I'm going to put x plus 3 equal to 0, 2x plus 1 equal to 0, and x minus 2 equal to 0. And I'll solve each one of those. So x is equal to a negative 3, 2x is equal to a negative 1, so x is equal to a negative 1/2, and then x is equal to 2. So I have 3 points here. I have negative 3, 0, I have negative 1/2, 0, and I have 2, 0. And I know that they are negative 3, 0 because I plugged in 0 for my y here. I set it equal to 0, so my y is 0. So that's how I know that the point is negative 3, 0. Okay? Each of these, remember, are raised to the first power, so they all have a multiplicity of 1. So their multiplicity is 1. So that means that they're going to go through, since it's an odd, they're going to go through the point. So it's going to go through the point, and it's going to go through the point. Okay? The last thing that we need to find is our y-intercept. Remember that for the y-intercept, that is going to be 0, comma, a number. So we're plugging in 0 into our function. So I originally have f of x equals x plus 3 times 2x plus 1 times x minus 2. I'm going to plug 0 in for my x. So this is going to be f of 0 is equal to 0 plus 3 times 2 times 0 plus 1 times 0 minus 2. So I get 3, 2 times 0 is 0, plus 1, so that's 1. 0 minus 2 is a negative 2. So I get negative 6. So that means that my y-intercept is 0, negative 6. So I actually now have 4 points I can plot. And I also know something about the graph, its end behavior, and I also know what's happening at each one of the points. So let's graph this thing. Let me get some grid lines going here to kind of help us out a little bit. So if I draw my xy coordinates, okay, so this is your x, this is your y. I had, first of all, my y-intercept was at 0, negative 6. So 1, 2, 3, 4, 5, 6. So 0, negative 6. So this point is 0, negative 6. I had an x-intercept at negative 3, 0. So right here. So at negative 3, 0. I also had an x-intercept at negative 1/2, 0. So negative 1/2, 0. And an x-intercept at 2, 0. 2, 0. Okay, so I have 4 points on there, but what else can I do? I know that my end behaviors say this, that it's going to start out coming from the bottom and it's going to go through each of these points. So if I start out from the bottom, I'm going to go through this point, come up, go through this point, hit my y-intercept, and then go through this point. So I've gone through each of these points. My end behaviors are correct. Now I don't know if this height is correct or this height down here. I just know that I went through it. And that's the main thing I'm looking for, is I'm looking for, did you go through these 3 points? Did you go through the y-intercept? And is your end behavior correct? Okay. So I'm not going to be looking for some of the other aspects of this. So let's look at another example, because sometimes these are not all going to be factored for us. So if I have f of x is equal to 2x to the third plus 5x squared minus x minus 6. Okay, this one's not factored, so we're going to have to do a little bit more work on it, but I know that the degree of the polynomial is 3. I know that my leading coefficient is a positive 2. Therefore, if it's an odd and it's positive, I know that my end behaviors are going to be starting out down and ending up. And in this format, I can go ahead and say f of 0 equals 2 times 0 to the third plus 5 times 0 squared minus 0 minus 6. So f of 0 is equal to a negative 6. Remember that in this form, your y-intercept is the number without the x. So we have a point at 0, negative 6 again. I don't have my x-intercepts. Okay, so I need to find out what my x-intercepts are, or my zeros are. How I'm going to do that is using synthetic division. So I know that I'm going to pull off a 2, a 5, negative 1, and negative 6. We've already discussed a little bit about how to find possible zeros, and that is your constant divided by your leading coefficient. And so there are several different ones that I could use. Most of the time I start off with trying a positive or negative 1. So I'm going to try a negative 1 first. And let's see what we get. Remember that 2 drops straight down. 2 times negative 1 is negative 2. 5 minus 2 is 3. 3 times negative 1 is negative 3. Negative 1 plus a negative 3 is a negative 4. 4 times negative 1 is 4. Negative 2 plus 4 is negative 2. Okay, I don't have a remainder of 0 here, so negative 1 is not a 0. It means I need to try something else. So let's try a positive 1. 5, negative 1, negative 6. So I bring the 2 straight down. 2 times 1 is 2. 5 plus 2 is 7. 7 times 1 is 7. Negative 1 plus 7 is 6. 6 times 1 is 6. Okay, so this one gave me a 0. So I know now that whenever I get this 0, I can come over here and put an x-intercept at x minus 1. because remember I've got an x equal to a positive 1. And so usually if it's factored form I would say x minus 1. Now then I have 2x squared plus 7x plus 6. I can either factor this, use the quadratic formula, or I can use synthetic division again. I'm going to use synthetic division again, and I'm going to try another number. I'm going to use synthetic division on my new numbers here, okay? The 2, the 7, and the 6. And I'm going to use a negative 2. So I'm going to bring the 2 straight down. Negative 2 times 2 is a negative 4. 7 minus 4 is 3. Negative 2 times 3 is negative 6. 6 plus negative 6 is 0. So negative 2 is also an x-intercept. Now I have 2x plus 3 equal to 0, and I can solve this one because I can subtract the 3 from both sides and get negative 2x equals negative 3. Divide by 2, so x is equal to a negative 3 halves. So I have x is equal to a negative 3 halves. So now I have all of this information that I can use to try to graph it. Notice all of my zeros had a multiplicity of 1, none of them repeated, so all of them are going to go through. So let's draw, and again I'm going to do my grid lines so that it'll be easier for us to see. Okay, so let's put our x and our y there. Here's my x, here's my y. Okay, I had I had a y-intercept at 0, negative 6. So 0, negative 6. So 0, negative 6 was my y-intercept. I had an x-intercept at 0, 1. I'm sorry, 1, 0. Ooh. So 1, 0. I had another x-intercept at x equal to negative 2. So that's going to be negative 2, 0. And then I had an x-intercept at negative 3 halves, which is the same thing as negative 1 and 1 half. Okay? I also know that my end behaviors look like this. So I'm going to start out at the bottom, come up, go through, go through, go through my y-intercept, come back up, something like this. Okay? I should not have cut back over right here, but I should have stayed right through here. Let me try drawing that a little bit better through there. Let's see if I can, if I do that and erase all this other stuff. Okay, so that's a little bit better. But you kind of see how we're beginning to get some of the graphs. Okay, let's look at another example. And this time we are going to have f of x equals a negative x minus 1 times x minus 3 times x plus 2 squared. Okay, the degree of this polynomial, remember these have an understood 1, so it's 2 plus 1 plus 1, so that's going to be a degree of 4. My leading coefficient, notice, is this negative out here, so my leading coefficient is negative. Therefore, the end behaviors, my degree is even, and my leading coefficient is negative, so it's going to be both going down, just like a parabola opening down. To find my x-intercepts, I set each one of these equal to 0. So I'm going to say x minus 1 equals 0, x minus 3 equals 0, and x plus 2 equals 0. So I've got x is equal to 1, x is equal to 3, and x is equal to negative 2. Have to be careful here. Notice this. That means that this x equal negative 2 has what we call a multiplicity of 2. Therefore, at this point, it's going to bounce. It's not going to go through, it's going to bounce. These others are going to go through. Okay, so we're going to go through x equal 1 and x equal 3, but we're going to bounce at x equal negative 2. Then I need to find my y-intercept. Let's see here, my x-intercepts were 1, 0, 3, 0, and negative 2, 0. Okay, so my y-intercept, again, I plug 0, I say f of 0, and that's going to be negative, let's see here, 0 minus 1 times 0 minus 3 times 0 plus 2 squared. So I get a 0 times a negative 1 times a negative 3 times 2 squared. So negative times negative 1 gives me a positive 1 times negative 3. 2 squared is 4. So 1 times negative 3 is negative 3. Negative 3 times 4 is a negative 12. So f of 0 is negative 12. So I have the point 0, negative 12. Now I have all the information that I need to start graphing this. So let's see if we can graph it. Let's see if I do this here. Okay. Okay, so we're going to count by twos because my page is not large enough. So let's see. If I go 2, 4, 6, 8, 10, 12. So right here is my 0, negative 12. And then I have a y-intercept at 1, 0. So I'm going to count those by twos also. I have one at 3, 0. And then I have one at negative 2, 0. And I know that my end behaviors are going to be like this. So that means I'm going to start out coming from here. Remember, I had a multiplicity of 2 here, so I'm going to bounce, come down, hit this, go up. This one had a multiplicity of 1, so I'm going to go through it. This one had a multiplicity of 1 also, and I'm going to go through it. And then put my arrows. So remember, I bounced at this one because of that multiplicity of 2. You really have to pay attention to where your x-intercepts are, where your y-intercept is. Am I going to go through it? Am I going to bounce at it? And then what are your end behaviors? Those are the things that you're looking for in order to help you graph these. So this is section 3.4 that we're looking at. So go ahead and practice some of the homework and then let me know if you have any questions.